Sounds like someone's playing squash at your house. Okay. What else needs to go away? You're gone, you're gone, you're gone, you're gone. We need you. Good morning, Prack Tiny. What does that little robot head mean? Is it just a happy robot head, or is there some extra meaning? Just a smiley face. All right, I like smiley. Good. Well, I don't mind. It can have extra meaning too. Hero. Hero? Well, the turtles were heroes in a half shell. Oh, it just automatically makes the smiley face in the robot. Okay. I like that we've got turtle power, which is something from a long time in my past. What? Oh, my phone. I've got to, trying to use my phone in a totally ghetto way to have a little document camera. But that means I've got one more thing to look after. You'll have to tell me who. Yeah, go on. No, there will be no guest appearances today. The kids are at school, so no Scooter, no peering at the window, because he wants to see himself appear on the screen. It's going to be quiet. It's going to be weird, but I can keep the curtains open. Ah, wonderful. Thank you. So the little icon on the bottom of my restream thing tells me there's 16 people viewing. I don't know if that's accurate. It probably is, though. We did really get up to about 150, though. So I'll probably give it a little bit longer to see if more people come in. But is that, can you see how many people are watching on the stream, Cecilia?
I have 22 on Twitch and 17 on YouTube.
Ah, so it's just showing me the YouTube number. Now that's a dog. That's a happy dog. What does a dog mean? Does it just mean dog? Or is it a doge? I'm such an old person. How do you pronounce D-O-G-E? That's a whole separate thing, right? Yeah.
There are heaps of cute little emojis.
I know, I can't keep up. It's a whole language of these cute little emojis that I don't know anything about. So if you want to talk to yourselves without the old man knowing, just do it in these emoji faces and I won't have a clue what you're on about. It does give me a report at the end of every stream telling me which were the most popular emojis. And I just see a bunch of different heads that don't mean anything to me. And I'm like, okay, whatever. All right. Twitch sent me an email the other day going, if I just stream a few more hours this month, I can become affiliate. I don't even know what that means. Sounds like hard work. We got enough to do, haven't we? Now they're showing me the whole stream. I can earn money. Yeah, that doesn't sound legit. Getting money for something that's already my job. Sounds dodgy. What do we do with the donations? I know what OnlyFans is, and I'm definitely not doing that. I did my shout out to the graduating students for free. If you, yeah. All right, 10:06.
Live on Twitch.
What was that?
5 on Twitch and 27 on YouTube.
Cool. That number's a strange number now because mine says 49, but whatever, we'll get going. Let's get going with our Kahoot. We've got a super short one, 1, 2, 3, just to warm us up this time. I did get a reminder from the uni that they still don't know how to do Kahoots without causing trouble, but I do, so we do it. Game options, friendly nickname generator. Off we go. I'm trying to work out what kind of prize I can offer. Yeah, well, it would be nice to have some extra uni funding, but getting it from the students doesn't seem so good. You guys are already paying. Oh no, the video's making sound. I don't need that. I chose to use Kim's video as the lobby video this time. So Kim started talking in my head as soon as I put that on. Oh, and it's a bad choice to use a white background. Lesson learned. So it's 3 quick questions. Bang, bang, bang. It's going to be a run for because they're super easy questions. It's going to be a tight run for the winner. So whoever's got low latency answers quickly, you'll be the winner. Everybody loves Kahoot. So I was asking the Comp 1010 people what alternatives there are, and someone suggested Jackbox. I'm like, okay, I know Jackbox. That sounds like the right kind of thing. But I couldn't work out how to make my own Jackbox game that would work as a Kahoot. If anyone knows, do let me know. Some very cool octopus made out of Unicode characters? No? $53. Whoa, that's a bit tiny. It's like watching popcorn in the microwave. You just got to wait until it doesn't pop for a second or two, then it's time to go. Man, I miss microwave popcorn. I only just replaced my microwave after like a year and a half. I can go get microwave popcorn now. Yes, that's today. Microwave popcorn. Squid, 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 squid. Yeah, we all do. Microwave popcorn's awesome. And the kids aren't in the house, so I get to eat it all myself. That's not going to end well. Too much saltiness. Okay. All right, let's go. This seems weird just chatting about random stuff, but what else are you going to do? This is a new online word. No, it doesn't mean we can use Kahoot for 1010 now. The uni still says don't use Kahoot. Why am I using Kahoot here but not in 1010? Because this isn't a lecture. And I'm like, wow, I can probably get away with it. Uber Eats popcorn. I see so many people Uber eating things they can just microwave themselves. Oh my lord! And by the time it comes from the restaurant to your house, it might as well have just been microwaved. We are on, like Donkey Kong. 30 seconds for each one of these. What is stored in a memory slot for arrays? Red, the whole array. Blue, the memory address of the array. Yellow, the first element of the array. Green, a reference to the array. Just one answer. Uber Eats is not so great out here in the suburbs either, by the way. They're like 15 kilometers from the most. There we go. So there were 2 correct answers because both those blue and green mean the same thing. A memory address of the array or the reference to the array are the same thing. Just different ways to say it. So either of those is correct. But that's right. We can't fit the whole array in. So we do that instead. Next question. You better be quick on this one because this is just super obvious. Oh, we've got to find out. All right, that was quick. See, I told you it was going to be a race. The race between the Wildcats. What is stored in the memory slot for a p vector? Whoever's answered already, they're going to get the most points. I set this one to just have a single answer, but I'm sure you can all guess that there are 2 correct answers on this one too. Very good. I don't know what those 14 people were thinking. I mean, it's true that 3 values are a lot less than whatever you might have in an array, but p-vectors still don't store them all in one slot in memory. You have a separate reference that points off to that other slot in memory. And that could, so what I'm trying to point out here, I guess, is that the reference we've been talking about is exactly just the memory address. So your computer memory is this huge big bank of memory. Every slot has an address. It's a 64-bit number. And 64-bit numbers go very high, so you can have lots of slots in memory. So all a reference really is they just fill that. We don't need to know this, it's not important, but they fill the cell with the actual memory slot that it's the memory address that it's talking about. And so that's what an arrow is. It's just over there, please. Nice work, Wildcat. I knew it would be a shootout between the Wildcats. Nice work. All right, have your wits about you for the next one because you want to be quick, but you want to think. I put color in inverted commas there because I'm talking about the type, the built-in type in processing that is color. We haven't used it, but we have talked about it along the way. There was a lecture one day when someone said, how does this thing work? And I spent some time explaining it. Oh, I put the wrong answer in. So I've messed you all up. I apologize to those 3 people who picked red. So who picked red? You got to tell me where your code was for who picked red. There's only 3 of you. So one of those 3 is going to be the winner. I messed up. The answer is the whole color, not the red component of the color. The whole color. That's why I was tricking you here. I tricked myself. Did this on my laptop in the car while I was trying to drink a coffee. That's my excuse. Snowy Tiger, did you pick the whole color? Anyone else want to claim having picked the whole color? In which case, Snowy Tiger becomes our winner, and we'll assume they got the other 2 correct. But how does this work? This is a magic. This is a trick. The color type in processing is not a reference type. So we messed up our podium. I always mess these up first time around. A hollow victory for Red Wildcat because they were actually wrong. All 3 of you were wrong. What are we talking about with color? Let me show you. I wanted to catch you out with that one. It's always good to have a gotcha question. I did warn you there was a gotcha question coming though. Nobody realized. In fact, less people go. Oh, it doesn't matter. Right, I'm going to leave that one. I'm going to fix that one right now so I don't forget. The whole color is the answer. Where's the edit? Not the red component. The whole color is stored in the color. Done. All right, let's hit the processing reference. And I just want to show off something that's important to realize. Done, go away. Oh yeah, I don't often get to reuse them, but I always think to myself, maybe I can use that same one next year. We'll see. But I've redone them all this year because doing them online is different to doing them in class. But I guess we've got next semester. I'll probably try and use that one next semester. Are you going to pass on the results to someone doing it next semester so they can ace the Kahoots? So the thing I wanted to point out is how to know the difference between, because we're learning now about reference types versus value types. So we do know we've got some emails from the Vice Chancellor. Check your emails from the Vice Chancellor about what's happening next semester. Bouncing around a little bit, but the short answer is online classes and some access to campus. So we'll still be running our lectures this way, I guess, or we might be able to switch to Zoom because we'll have less people in second semester. And we'll still be running our class. Anyway, back to the material. We'll discuss all that stuff at the end. let's talk about material. So we hit compound data, right? That was last week's topic. And in compound data, we discovered that data is not stored directly in the memory cell anymore, but you get a reference off to that memory cell instead. And we're going to see today that that has big consequences for the way that data works. So it's really important to know when you're looking at a data type, when you're looking at a value, sorry, whether that value is going to act like a value type or it's going to act like a reference type. And so how do you know which one's which? The short answer is, if the type of that value starts with a lowercase letter, Boolean, byte, char, double float, int, long, the ones we're all familiar with, and the color one we didn't use starts with lowercase, it's going to act like a value type, and the entire value is stored in a memory cell. If the value you're thinking or looking at comes from a capital A type, array list, so that's where we have p vector is in here. There it is, capital P vector, capital S string, capital I image, capital P font. Images is here somewhere. Then those ones act like references, not like values. Yes, string arrays are in the scope of this course. We talk about strings and we talk about arrays, and there's no reason you can't put a string in an array. It might be a fun thing to do today. Actually, it would be a fun thing to do today. Let's totally do that. All right, so let's keep that in mind. And we went through, I remember we did in one of the lectures, so I guess you can look it up in the lecture recording back when we were on campus. We talked about exactly how a color, which is really 3 values, gets jammed into 1 value. It's a cool trick that processing does. Excuse me, it's called integer bit packing shifting stuff. It's not called that at all, but that's what I call it. I've never had to do it in anger because it's something you generally used to do a long time ago. Dookies. What are we talking about? We're talking about the consequences today. Oh, go back to our ads coming up for cheap tents. It's always cheap tents. Can you guess what I'm going to do as soon as I'm allowed out the house? I'm going to go sleep in a tiny little box somewhere with nobody around me. Okay. Now I'm looking down at the 110 stuff. So we are here on reference semantics. So today we are following today we are following all of the consequences of the differences between value types and reference types. And one of the big consequences of that is, how do multi-dimensional arrays work? So we'll talk quite a bit about multi-dimensional arrays. That's our biggest, perhaps our most complicated example of a reference type. And they're very commonly used, and there's a lot of examples, a lot of situations where we have to use them. They're a great example to go off. But let's just talk about fundamentals at first. So the fundamental thing we're talking about, sorry, I should have also said back then we did the lowercase for value, uppercase for reference. Then we add to the list of reference things arrays. They act like references as well. Even though it starts with lowercase I, this integer array acts like a reference, not like an integer. So the two of these two are definitely going to act differently by the reference and value semantics, yeah? So I'm going to do something tricky. I'm going to make x's an array that's only got 1 number in it, which I'm allowed to do, but that means I'm really doing, I've got 2 versions of the exact same thing here. And if you remember, when I build something to reference value, so an array or a p-vector, I've got 2 steps. I can't just go straight from declaration to assignment. I have to do declaration, memory allocation, and assignment. So I need my memory allocation here, which is where I say, I want this to be an integer array with just a single element, and it does its business. And then express. So I'm going to use these somewhere to try and show off the difference. How can I possibly show off the difference? Well, what I'm going to do is I'll draw a circle using one of them and a circle using the other one, and we'll see if the circles behave a little bit differently. To make it work differently, I'm going to have to introduce a local variable, because if I just access the global variables, I'm not going to see the difference. There won't be enough of a, won't be exercising the actual thing we're talking about. So I'm going to make some local variables. Maybe they're kind of useless local variables. We would think of them, but they're there to make sure the example's doing what we want. So let's say I'm going to use the x position, the x value I've got there for the x position of a circle, and I'm going to use whatever I find in x's at position 0 for the y position of the circle that I'm drawing. So I've got some globals, and in this case I'm just accessing them directly, but I've decided x position will come from that global x, y position will come from the global x's, which maybe is a little bit confusing, but that's okay. And I'm just going to draw an ellipse using those. So x pos, y pos, and no, that doesn't do what I want, does it? I better go look at my known examples. I'm going to have to do it with functions straight up, basically, is what I'm saying. I was trying to do it without functions, but I'm not going to be able to. So let me talk about the mechanics of what I'm talking about first. I've got my my very lo-fi document camera, which keeps turning itself off, and then you get to turn it back on, and then it points mostly at the wall. But I do want to just, let's get rid of this code that's probably just going to confuse things. Oh, sorry, there's a missing step up here. I haven't made these the same yet, have I? X is 0 equals 5. So what do I get in memory if I run these 3 lines of code is the question. Can't make that any bigger, unfortunately. Can't make a point anywhere more useful, unfortunately. Okay, so remembering that memory is kind of a big bank of squares. I'm at work, I get to print this out so I don't have to draw it every time, but no printer in my house. Who's printer these days? So that's my memory. So the first line, int x, will set up a slot in memory and call it x. And the second line, int square bracket, x's will set up a slot in memory, doesn't matter, somewhere else. I try not to draw these next to each other because we don't actually know where they are. And call it x's. So that's all they do. They both do the exact same thing, but this one's ready to store an integer and this one's ready to store an integer array. Then when I do x equals 5, the result is putting 5 in here. And then when I do x's equals new int 1, that's the same as saying, okay, I need 1 block, so it makes 1, and I need x's to point there. So it does that. Then this one here, x's, sorry, also when it does that, it sets up numbering on each one. So this one's numbered 0, and there are no others, so we don't have more numbering. So x is 0 equals 5, then goes x's 0th element, 5. So what I want to show you is that even though both of these is just storing the number 5, they're storing it in completely different ways. And that has consequences for the way the program operates. All right. Let me see if I can construct this example again. So I had, oops. Sorry, I'm just trying to think on the fly. I know how I can make it work with a function, but I'm trying to make it work without functions so we can do the simpler version. Another one points to the same place and that follows the other one. Okay, so that's what I'm doing wrong. So let's say y pos. I'm just going to say, you know, the x pos comes from x, the y pos comes from x's for whatever reason, and then draw the ellipse, please. Now this won't work because x's itself is not an integer, right? It's an integer array, so I better do that. This is a weird thing to be doing, right? But I'm just trying to set up the situation that will cause what we want. Okay, then what I'm going to do is I want this thing to animate down the screen in a diagonal. So I'll xpos plus plus and I'll ypos 0 plus plus. So whatever I'm doing, you can think to yourself how this is going to run, but whatever I'm doing, it looks like I'm doing the same thing to the x and to the xs, right? Fingers crossed. Oops, it should be a 0. Fingers crossed. That should be a 0, because ypos is not an integer, it's an integer array. Yep, it's only animating in the y direction. The x direction is not animating at all. In fact, if I think about this, I probably expected neither of them to animate. But let's go through the memory to see exactly what's happening here. So on each frame, I can see that the y value, the one that's being used for y, is updating, and the one I use for x is not updating. Why is that? Well, when I do, move this over in case my head's in the way. Just realized I've got a head on the screen that you guys can see, but I can't see. When I do xpos equals x, sorry, int xpos equals x, that does two things in once. That declares an int xpos, so another slot appears, and it's called xpos. And it goes and looks in the value x, finds out what's there in the slot x, and puts it in the slot ypos. So it looks in here 5 and puts 5 in here. Then when I did int array ypos equals x's, the exact same thing, right? It declares a new slot, takes the value from this slot, puts it in this slot. Well, that looks like this. Let's use this one. Declares a new slot, gives it a name, takes the value from x's and puts it in ypos. Well, the value from x's is this arrow, so it puts this arrow in ypos. There we go. So you can see these are, oh, my camera's gone. Oh, the boy did make an appearance today. Can't keep him out of it. It declares the ypos slot and then copies whatever's in x as into whatever's in y's. Well, the thing that's in x's is the arrow, so the arrow gets copied across. So now you can see again the situation is different. So hopefully you can see now why the animation is going to work different in each dimension. But let's just follow it through. So then we look up xpos and we draw it at 5. And then we look up ypos 0, which is ypos 0, and we get 5. That's fine. But what happens when we do the increment? Well, xpos plus plus goes to the xpos slot and updates it to 6. Cool. But you can see the problem here because I've updated the xpos slot, but at the very start of the very next draw loop, what am I going to do? I'm going to create a whole new xpos. I'm going to copy it across from x, and I'm just going to get 5 again. I updated this local variable 6 to 6, but the local variable doesn't survive. It goes away when call's finished, and a new one comes and gets the value of 5 again. So it's always going to stay 5. That's just always going to draw at an x position of 5. That's why the x didn't animate. But the y did animate, so why was that? And that's because when we did ypos 0 plus plus, it said go to the ypos slot, follow it to where it goes, and increment what you find at the other end. So it incremented this guy. Okay, so now we can see this guy is still linked back to the global. So there was a completely separate local variable created over here when we copied over a int. There was a shared variable set up when we copied over an integer array. And that's the different behavior you get from value types versus reference types. The fact that they're stored in memory a different way means that they act differently in your program. So the main thing you've got to remember is that it all comes down to the equals. The equals, which is an assignment, right? Assignment acts differently for value types versus reference types. When you do assignment on a value type, the value from the right is copied over into the left. When you do assignment on a reference type, the value from the right is copied over to the left. Hang on, I just said the exact same thing. Okay. The difference is what the value is. Here the value is the whole value. So let me rephrase this. When I do an integer type, the whole value is copied from the right to the left, because that's what's inside the x. When I do a reference type, the reference value is copied from the right into the left, because that's what's stored in the slot. Okay? So in a sense, nothing's changed from what we learned last week. What we learned when we did variables, where we learned that, you know, you look up a slot, you find out what's in there, you put it in the other slot. That's what assignment does. What we learned last week was the thing that goes in the slot is a reference instead of a value. This is just the consequence of that. But an easy way to remember the consequence, and a way this will sometimes be taught without teaching you any of this stuff about the memory, is just when you copy reference types, you get a copy of the reference. When you copy value types, you get a copy of the value, and you can move on from there. I find you have to know a little bit more about what's going on underneath to properly understand it, but that's okay. So there are two levels at which you can understand this. You can just understand the consequences, and if you can memorize that, you'll get a certain distance through the course, probably enough to pass. But if you can understand what's happening underneath, you'll do better. So the consequence comes up on assignment, simple enough, yeah? Are we all happy with that? Yeah, so if I replaced x plus plus with x plus plus, it would move, exactly, because I'd just be talking entirely about the globals. And that's why I had to do this weird thing by introducing a local variable. Because it's only the fact that there are two variables kind of talking about the same thing that we get this strange behavior. When there's just one variable talking about the thing, you won't find it problematic. But there are lots of times where we get two variables talking about the same thing. And I'm going to show you that situation now where it's unavoidable instead of just weird. So the time we get an unavoidable extra variable is when we're using functions. Yeah, then you need to change the ellipse to x, that's right. Now what I'm going to do is I'm going to switch from using an array to using a p vector, because I think the comparison is useful. And then we might have done this last time, right? It's hard remembering what we did, but now I'm going to put in two different so I'll have an x1 and a y1, and I'll have a pos2, right? So I've got two different ellipses being drawn in this case. One, because I'm using the old style integers, I have to keep its x and its y. But the other one, I'm using a p vector, so I only need one variable for it. And I'm going to set up x1 equals 0 and y1 equals 0. So you can start on the top left. And again, pos2 is a reference type, so I've got to do pos2 equals new p vector. And I'm going to start it at the opposite corner, width 0. So it's starting over on the right-hand side. Simple. And I'm going to draw two ellipses now. So I got an ellipse at x1, y1, and I've got another ellipse at pos2.x, because that's how I get the first component, and pos2.y, and it's also 80, 80. So I think that just draws two circles, that's not a problem. And now what I'll do is I'll globally adjust them both so they're both animating. x1 plus plus. So I'm going to make this one move across to the right, and I'll make the other one move down in a diagonal. So that means that pos2.x has to be minused, and pos2.y has to be plussed. And then it should go down in the diagonal, I think. That's because you're pos2, not pos. Good, so they're animating the way I want. But let's say, just for argument's sake, that I wanted these animations to be quite complicated. I wanted them to do some cool maths and, you know, go fast and then slow, or slow and then fast, or just bounce back and forth, or whatever. I just wanted to move the logic for the actual movement off somewhere else into another function. Maybe it was a function that was built into the library, maybe it's one I wrote myself. So I'm going to do that. I'm going to write a couple of functions that do the movement for me. I'm going to make a function called moveRight, and it can take in two parameters, right? An x and a y. So when you take in an x and a y, you don't actually need the y, but we're going to put them both in just for fun. You have to go x plus plus and nothing. You don't have to do anything on the y. Good. Maybe I'll make a move left as well. And just for fun, I'll make a move down left, which is what that other one was doing. So I don't do anything for the y because moving right doesn't change the y value, it stays the same. I'm just putting it in there to make everything match. Because now when I do move down left, I do have to do x minus minus y plus plus. I have to change both of them. And also because I'm about to write p-vector versions of all of those. Because I was storing one of my things as an x and y, so that was fine. But also storing the other one as a p-vector, so I better have p-vector versions of all these, right? I'll do those. One of the cool things about processing is that I can have the same function name with different parameters. So when I do the down, oops, I'll tell you what, I'll just do the down left one for the p-vector because we don't really need the others. So if I was doing this on a p-vector, instead of taking in two integers, I would take in a p-vector, right? Pos. And I'd have to do pos.x minus minus and pos.y plus plus. So I don't really need the move left and move down left. I just wanted to show you what they would look like so that you can see the exact equivalent that comes on the p-vector. Because really all we're going to do is use move right for this guy and move down left for this guy. So instead of doing this ourselves, we're going to move right x1, y1. Those are the x and the y that I want, and move down left pos2. So remember, the only reason I'm doing this is that maybe move down left has got some fancy maths so that the animation happens smoothly, or maybe I'm, you know, goodness knows. All right, good. What am I expecting? Well, I'm expecting what I had before, one of them moving across to the right and one of them moving down to the left. All I've done is put it in functions, but that one circle stopped moving. If we go back to our variables topic, if we go back to our functions topic, this is exactly what we expect. We expect the left one not to move, not think about the right one for a little while. Let's just think about the left one. I want to step back and just remind you what happens in function calls. So we'll look just at this move right. This guy here into x. So we called that the formal parameter of the function signature. Those were the terms we used. And we said that's a declaration. Looks just like a declaration. It is a declaration. This one here is a declaration as well. So the start, anytime you hit a function, anytime you call move right, it's exactly the same as setting up two new declarations, just like we did before when it made no sense, but now it makes some sense. And then when you call the function, putting x1 into the actual parameter slot is identical to saying int x equals x1. That's really what's happening. The declaration from down here is run, and the value from here is equaled against it, assigned to it. And then the next thing, because there's two parameters there, we also get int y equals y1. So those two things happen when we call the function. Brand new declaration, value copied into it. Brand new declaration, value copied into it. Exactly like we did before in our memory diagram, except with two of them instead of one. So I will quickly draw it because I want to make it clear. Frozen up the camera again, turns itself off. And then when we turn it back on, we get a glimpse of the boy, and we're back. I was checking out the latest stuff from Daniel Schiffman, and he's doing stuff from quarantine in his home. He's got a lovely little cabin in the backyard, and he walks down there with his dog. It's all very, van life. And I was like, gosh, he looks good. They gave a wide shot, and he's got like this super fancy document camera, 5 little cameras set up around him. I'm like, lucky him. But we can do just as well with our little kiddo set up here. Okay, that's the MIT Media Lab for you. That's what Media Lab money does. Good on him though, he's making good use of it. So check it out, he's still doing useful stuff. It's quite advanced what he's doing at the moment. He was doing a noise generating function for Wall-E noise. Was the latest one. Okay, so this program has got an x1 and we're just talking about x1 and y1 for now. So when I did the int x1 at the top of the program, I made myself a slot and set it to x1. And then I did the same thing for y1, made myself another slot and called it y1. So then I made this function declaration, but function declarations don't do anything. They're just there ready, waiting to go. Nothing happens. There's no memory slot set aside, nothing from a declaration. It's just, ready to go. But as soon as I do a function call on line 20, then the function declaration is like fired up. So we jump down to line 25 and we have the equivalent of, it's the exact equivalent of int x equals x1 and the exact equivalent of int y equals y1. And we know that those two lines make another slot for us. So that's just, the values that were in here were 0 and 0, right? We know that a declaration and an assignment means make a new slot, call it x and copy the value over, make a new slot, call it y and copy the value over. So we can see now why x plus plus, which we did on the next line, made no difference to x1. It only made a difference to the local variable and totally what we expect in the end, because we know that values get copied over when we write functions, yeah? So why did it work for the other one is really the question. Well, the reason it worked is because this step of declaring a new local variable and assigning a value, declaring and assigning, which is what happens when we call a function, works differently for reference types. When we did the move down left, so we'll go back, the pos2 was declared as a p vector, so a slot was made for it. And then there was a call new p vector, which created these 3 slots for us. And we filled them in with the values. How big was my screen? 800. We filled them in with the values 800, 0, and 0, and made the arrow go like that. So the declaration was different. So then when we did called the function, which was, I'm running out of space, so my apologies, move down left with pos2. When I did that, it was the same as p vector pos equals pos2. That's the mechanics of having the signature looking like that and the function call looking like that. As soon as we call the function, the signature fires up and this declaration occurs, and the actual parameter is assigned to the formal parameter. So that line p vector pos equals pos2 means make me another slot, call it pos, and copy across pos2. Well, copying across pos2 means doing this. So now you can see why it's working in this one. Because inside the function, when I do pos.x, I'm talking about the very same value. And when I do pos.y, I'm talking about the very same value that pos2 is pointing at. So the fact that when we pass a value in to a function using value types, we get a complete copy. When we pass a value in to a function using reference types, we don't get a complete copy. We get the reference copy. Gives us very different behavior for function calls. That's the main point to take home here, is that function calls work differently. But of course, the mechanics of how it works is super important. So let's questions on that before I move on, because now we're going to think. That's really all I want to say on the function call side of things, but I'll think a little bit about some consequences from this. Okay, Cecia's got that question. So one consequence is that functions here might be able to change the parameters you pass into them. When you were calling the line function, for example, you were sending it across your global variables all the time. We did it, well, when we called the lips, we sent it two global variables, x1 and y1. Imagine if a lips might have been able to change those. Then every time we call lips, our globals might just change without us even thinking about it. That would be bad. It's generally a bad thing that functions can change variables for you, because you're calling them without really knowing how they work. That's the thing we've got to be wary of. We've got to be wary of that once we switch to references, when they get passed into a function, they might change underneath us. And that kind of change at a distance is bad from a programming point of view. And so most people will prefer the value semantics. But there's no way. Right? The fact that you prefer it doesn't mean you can just enforce it. Reference semantics are an unavoidable consequence of programming. So this shows up when we're doing arrays. There's a cool trick we can do with arrays that we can't do with other values. Done. That's a step ahead. You might have noticed that when we're doing arrays, it's a pain to initialize them. Not too much of a pain, but it is a pain. When I want to initialize a variable, I just chuck a number in. Done. But if I want to initialize a variable, an array that's got, say, 800 elements, it's more work. I'll write you a program to show what I mean. So let's write a little program that just has randomly moving dots. Some of them, they'll start in the middle, and they have random directions of movement. Some of them are going up, some of them are going down. And I'm going to keep an array telling me for each dot on my 800 point line, which ones are going up and which ones are going down. So what I need is a Boolean array in this case, because I need a true false. Now I have to think to myself, which true means up or down. I'll just put this in a comment. I'll just say true means up to help me keep track. And so now I have to do the two steps that are required to create this array. I've got to do the memory allocation and the initialization. So memory allocation is easy enough. And I want it to be 800. I could use width as well, because I actually want one dot all the way across the screen. Maybe I'll do that. That's cool, the memory allocation is cool, but the initialization is a pain. I've got to go through every single slot in the array to do the initialization. Well, at least I know how to do that. For int I equals 0, I less than, I should use up or down dot length, I plus plus. Then each slot gets a random true or false. Whoa, random true or false sounds like fun. Let's go. So I'll generate a random number, and then if that random number is bigger than a half, I'll make it true, otherwise I'll make it false. Good. So that will be up or down slot I is equal to random 0 to 1 being greater than 0.5. All right, so that random 0.0 to 1 generates me a float. And then I compare that float against another float to get a Boolean that I put into there. Yep. So now I'm just going to draw that as well. Void draw. So background 0. So what I'm doing is I'm just drawing a dot. Hang on. I need to remember the position of each one as well. Okay, that's okay. Every variable needs to know its position. This time the position's just in the y direction, so I won't bother keeping an x. And then I can create that one too. I see stuff happening on the chat. I can't keep track of it though, so I'm just letting it go. Cecilia will work it out, I'm sure. And I have to initialize that one as well. Oh gosh, this is a pain now. I need another for loop. But this time I'm going to initialize all of the pauses just to height onto so that they sit in the middle of the screen. That needs to be pause. And okay, so now I've got the bits I need, so I can draw that. I'm going to do a point, and the point is at. So I've got many points. I've got to do 800 points. So I've got another loop. And I want to draw a point. The x parameter is going to come from the I, so that way each one's just drawn one dot across. But the y parameter is going to come from that pos array, and it's just a dot, so it just goes like that. And then I want to animate them. So if it's true, I want it to start moving up, and if it's false, I want it to start moving down. So I need yet another loop. Can you see how tedious all this looping is getting? So now I want to do an if statement, because if up or down I is true, then pos I goes up, else pos I goes down. Other way around, pos I goes down, else pos I goes up. Now let's put my my braces in, because I'm a good programmer. And finish off the draw. So there's lots going on here, right? They're all happening in loops. So if we really just look at it one line at a time, it's a bit easier to follow. I go and I decide whether there's a up or down randomly. I set the initial value to height on 2. Then I draw that slot, and then I animate that slot. If I'm going up, I minus minus off the y. If I'm going down, I do plus plus on the y. That needs to be pos I, because that's an array, not an integer. Notice that it's telling me every time I accidentally do it, cannot convert from an int to an integer array. And I got absolutely nothing there, probably because the stroke is black. Yep, there we go. Oh, okay, so there's the dots randomly going up or down. Okay, so what I wanted to show you, that was just an example to get going, but it has forced us to use arrays a little bit. What I wanted to show you is that this can be a little bit awkward here, this where I have to loop over the array and set its value to something every time. I guess it's not that bad. But the fact that I can change arrays in a function means there's another way I can do this. I could write myself a single function that I could use over and over again called fill array. where I give it an array that I've done the memory for, and I give it a value, and then it puts that value all through the array. That would be cool. So if I've got this fill array, it needs to take in an array, right? And it needs to take in a value that's going in that array. So the cool thing about reference semantics is that any changes I make in this function will be affecting outside, so that I can put the whole loop that I had up here into that array, into that function, sorry. Just change the names because we're not doing it on pos anymore, we're doing it on R. And we're not filling it with height on 2, we're filling it with value. And after this function is run, instead of getting a whole nother copy of array and not having those changes visible outside of array, I actually just get those changes visible outside of array. So I can have a function that does something to a variable for me. And that is quite useful when we're doing reference objects, because the processing of those reference objects, those reference values, can be more complicated. So it's great to be able to send that off to someone else to do. Let's just check that this does do what we want. Yeah, cool, the exact same animation. Okay, seems to be struggling a little for some reason. Okay, so I want you to realize that this is only possible because pos is a reference type. If I tried to initialize some value type by sending it off to a function and having it come back, it wouldn't have worked. I would have had to send it off to the function, and then the function would have had to return for me explicitly the new value. But with arrays, I don't have to, which is nice. Okay. Next consequence of this is how, well, questions first before. Let me check what we're going on. See if it's got it all sorted. But are there any other questions you might want to ask on this? Yeah, if you don't do the memory allocation step, then it's null. So after this line, after line 2, both of those are equal to null. After line 8, they're not equal to null anymore. They're now equal to an array that's got all zeros in it. And then line 10 is when we fill it with actual values. There's those 3 steps. Yes, exactly. So the question is, can you have an array that's got like 300 slots? You're not using them all, you just maybe use them later. That's totally okay. Yeah, and I can think of an example where you might want to do that. So I think, did we do an example of that before where we only partly use an array? Yeah, we did, because I'm sure we did. I seem to remember doing it last week. Okay. So when we're doing the loop, the question is about the length. When we're doing the loop, remember that every array has this cool thing you can ask on it anytime you want, which is what length are you, and it will tell you back. In this case, pos.length is 800, pos.length is 800. It's 800 because we said it was 800 when we put this in. And that's fine. There's no magic, it's just the value gets put in a nice place for you so that when you do the loop over the array, you don't have to guess exactly how long is this array. You can always use the array name.length and you'll get back the exact right number. That's super useful down here because inside the fill array function, we know we got an integer array, but we have no idea how big it might be. Right? If I put the number 900 in here, I'd get an array index out of bounds exception. If I put the number 20 in here, I would not process the whole array. But array.length is always equal to the length of the array, so it makes it easy for me inside the function to get the right number. All right, so the next consequence of this reference semantics is that there's nothing stopping us, well, this is true from before, there's nothing stopping us from putting whatever we want inside an array. I could have, for example, an array of p-vectors. I could have an array of strings. They don't have to be arrays of integers or arrays of any base type. Even better, I could have an array of an array, or an array of arrays. And that's what we're going to look at now. How do we deal with arrays of arrays? Whew. So arrays of arrays. What I'm going to do now is I'm going to make an array of arrays for every single pixel on my screen, which is a bit ridiculous, but kind of fun. So I just did an array for all of the pixels in a line. But what if I wanted to represent, let's say, the color of every single pixel on the screen? So this is an 800 by 800 screen. I could have an array that was, what's 800 by 800, 64,000 or whatever it is, array that long, and do some clever math so that I knew, that position 800 was, sorry, that if I was doing an x of 0, I was in the first 800. If I was doing a y of 1, I was in the next 800. But that's too much work. Much easier just to kind of store the two-dimensional array of pixels in a two-dimensional kind of structure. And an array of arrays is perfect for that. So we've shown you in the notes how arrays of arrays are really stored. Whoops. So they're really stored in the same kind of trick here. I'll just set one up for you. I'll set up one up and build up to it. So there's a video from Sarah which will be very helpful. Make sure you watch that. Well, on multi-dimensional arrays. And Kim talks about it as well. So here I am again. I want to show you the two different notations we use. The second one's much more useful in reality because the references get out of hand once you do arrays of arrays. So arrays of arrays have a syntax super simple, which is just use 2 square brackets. So that's saying I want an array that's not an array of integers, it's an array of integer arrays. So that's a declaration, right? So it does the same thing declarations always do. Just set aside a box and give it a name. But there's a shortcut in processing to do the whole next, because you got to do memory allocation, right? You can tell it both dimensions. Let's say we do 2 and 3. So you're setting that up to be an integer array with an outer dimension of 2 and an inner dimension of 3. That will do this for you. It will set up the outer dimension first and point to it and give it 0, 1. And then it will set up each inner dimension for you. And give those numbers 0, 1, 2. So that's what a multi-dimensional array really looks like in memory. Find that's too hard to write. So what we do instead is we just kind of shrink that notation like this. There's an outer dimension, and then there's the inner dimensions. Ooh, we've run out of space a bit. And the outer dimension is 0, 1, and the inner dimension is 0, 1, 2. But we want you to know that two-dimensional arrays, so to speak, can you see how this kind of looks like a table? Two-dimensional arrays are actually arrays of arrays. There's an array at the top, and each element of the array is another array. And that can help you really easily work out how to look them up, right? Because if I ask for a slot 0, 1, which slot am I talking about? Well, I'll go to the outer array and look up slot 0, and that turns me another array. So in that array, I look up slot 1, and I'm talking about that one. Back on the memory diagram, that means A to 0 to 1, this guy here. So multi-dimensional arrays are cool. You can actually do 3, 4, 5, 6, however many dimensions as you want, but they get to be a bit of a pain. So now I'm just going to do a quick example to show off the syntax of multidimensional arrays to make sure you got that sorted. Tons of videos in the notes on this, right? I don't need to give you a tutorial on it because it's elsewhere, but I'm going to do a real example to show it off. And the real example is going to be, I'm going to represent my whole screen. Each pixel on my screen is going in an array. And when I press on a pixel, it's going to change the color to a new random color, just for fun. Okay, so should it be a whole new random color? Yeah, we'll be using the color parameter. No, let's go to a new shade of gray. Random shade of gray, or just switch from black to white? Let's switch from black to white. So it's a Boolean, there's only two values, black or white, so it's a Boolean array. And I better tell myself that true equals black. Okay, so if I've got an 800 by 800 screen, so it's not a Boolean array, is it? It's a Boolean two-dimensional array, an array of arrays. Note also that the syntax here is just the same syntax you would naturally come up with for arrays of arrays. If int meant integer and int square bracket meant array of integers, then int square bracket means array of integers. So Boolean square bracket means array of Booleans. The memory allocation, I have to tell it both parameters at once. Ooh. And now I need to initialize that as well. So in this case, I just want to initialize it to, we'll make them all black. So I'll initialize them all to true. All right, so hang on. All of a sudden, I've got a loop over 2 dimensions. Let's think what I might do, just logically what I might do from what I see here. Still good, but now if I've got an array of arrays, to process it in any way, shape, or form, I'm probably going to loop over that outer array. And for each element of the outer array, I'm going to loop over the equivalent inner array. And if I do that, I'll visit this, and then I'll visit this, and I'll visit of everything. So if I'm looping once, and inside that loop I'm looping again, I must have a nested loop. If I think to myself, how many times should the outer loop go? Well, it's exactly the width of the outer dimension. So if I ask for the two-dimensional array dot length, I will get the length of the outer dimension, not the length of the inner dimension. So that's perfect. But inside that, I need to loop again, and it's standard practice to use J for the inner loop. But now, where do I stop on the inner loop? Well, look at the picture here. The inner loop goes over. The inner loop goes over the outer loop, stores an array that is the inner loop's length. Like inside slot 0 of the outer loop is an array. So if I ask for slot, in this case I, of the outer loop, I'm getting back a one-dimensional array. And anytime I've got a one-dimensional array, I can ask for its length. So that works as well. And this becomes our standard pattern for looping over two-dimensional arrays. We ask for the dimension of the outer, so the length of the outer dimension, and then we go in and we ask for the length of this particular inner dimension. It'll always be the same, it'll always be height. And then we loop that many times. So now I is indexing into the outer dimension, J is indexing into the inner dimension for us. And I can do black or white, outer, inner equals true. In this case, I just want to set them all to true. So that'll give me a black screen. All right, so that's the general. So these are the three things we need to know for setting up a two-dimensional array. We need to know the declaration syntax, which looks like this. We need to know the memory allocation syntax, which looks like this. And we need to know the access syntax, which is just give two sets of square brackets with the outer dimension, the inner dimension, and then make sure that's in a loop so that you can make some sense out of it. You can access them one by one if you want. We'll do that when we get to the mouse pressed. Okay, or maybe we'll do mouse. But the underlying operation of this is all governed by just standard array stuff. We're really just learning a tiny bit. It's not really new syntax. It's the same syntax. We're just showing how to layer it. All right, so in this case, these are all dots on the screen. So really what I want to do is just loop over. Whoop. Just loop again. I'm always looping. But in this case, instead of setting it, I want to use it. So I want to say, if that equals true, remember this is just going to go like 0 to 800 in that direction, and on the 0th one, it's going to go 0 to 800 in that direction. So it's just covering each pixel. And I've got an outer and an inner dimension. It's entirely up to me whether the outer dimension represents the X or the Y. But in my picture, it looks like I've done the outer dimension as the X and the inner dimension as the Y. So I'm going to stick to that. So if ij is true, then stroke, we said true was black, else stroke white, and then no matter what, draw a point at the position ij. And because I said I was, the outer dimension was X and the inner dimension was Y, that's what I get. Let me just set up the background to be black. Well, I set up the background to be white this time so we can see that it's doing black for everybody. I should get a black screen here, right? Oh, well, that's taking a while, isn't it? Boom. It's very slow. That should not be a huge surprise. We are going, this is an 800 by 800 array. So there's 800 in one dimension, and then each of those has 800 of its own. And we've got to go through absolutely every one of these to do this job. So the next thing I want to do is set up a mouse click so I can switch some of them from black to white. Let's do clicked. So if the mouse is clicked, I want to swap that from black to white. So the mouse X is going to tell me which outer dimension to look up. And the mouse Y is going to tell me which inner dimension. I'm just going to set it to false if someone's clicked on it. So fingers crossed I can now, change the state of the program. But I'm really concerned about what's going to happen because this is so slow. So I do a click, I wait that same amount of time. There, it changed to white. It took a long time to draw because this is going so slow because I'm doing 1 pixel by 1 pixel. There we go, I got another one changed to white. So this is me, like, we do it this way because it's a nice way to represent. The outer dimension is just all across the top, kind of invisible, and then each inner dimension is representing one of the pixels on the screen. That's far too much. So what would make more sense here is maybe use a smaller screen and see if that helps. I'm a little bit surprised my computer can't handle that. So that's quicker. Still not very quick though. We've broken it. Oh, that's still going. Oh, I must have been moving when I clicked. Anyway, That's an example of what we can do with two-dimensional arrays. It's also an example of the trouble we can get in with two-dimensional arrays. Arrays were great because they let us build big data structures in one hit. But when we nest them, now we can put big data structures in one hit. And we obviously got too big for the computer there. I just want to check to see if there's any. Oh, there is one silly thing I'm doing here, which is what's making it so slow. I know exactly what's making it so slow. Does anyone know what's making it so slow? Well, I think I know what's making it so slow. It's slow just because 800 by 800 is a lot. That's the first thing. So processing has different underlying graphics libraries. Or maybe if I picked a different graphics library, it would go faster, but I'm not going to get into that level of things. One thing I'm doing for sure that's not smart is every single pixel, I'm setting the stroke. And that's a lot of work. So I go through 800 by 800 times and I do an if statement and I set the stroke. Do you know what would be smarter? If I drew the background black and then only drew the white pixels. That would be much smarter. So let's do that. Well, I'll draw the background white and only draw the black pixels. Even when there's lots of black pixels, I bet that still works. So I'm going to set the stroke once in the setup to black. And then instead of doing an if and setting the stroke either way both times, I'm just going to say, don't do anything. Just only draw. It's always going to be black, so just only draw the white ones. Oh, sorry, just only draw the black ones. It's always going to be white, so always draw the black ones. Let's see if that's faster. Now, when I start this up, it's still drawing the exact same number, right? I'm still going through 800 by 800 and still drawing all 800 by 800 pixels. Will it be faster? No, not faster at all. So that didn't get me much of a win. So it wasn't the stroke that was slow. It's still just the going through 800 by 800. So now what I might do is, all right, if I'm mostly drawing them the other way, I should swap this around. Start with a black background and only draw them when they're white. Let's see how we go. Ah, so much faster. But nothing's happening on the update. I broke something. What did I break? If not black or white, black or white equals false. It's broken. The color's changed as well, hasn't it? That background's properly black when the other one wasn't. Anti-aliasing. That's what it is. It's the anti-aliasing. I think. Where is the anti-aliasing stuff? No smooth. I'm going to try that. Oh, yeah, stroke is white. I got to change stroke to white. That's what I got to do. Thank you. That's my error. All right, we're good now. It's not the anti-aliasing. I think actually the anti-aliasing was a problem on the other one though, but look how much faster it is now. All right, good. Good, good, good. So if I'm just drawing the white ones, it goes much faster. And I can probably draw a lot of them. I'm going to change this to mouse moved so that I can change lots of them. Because now it'll pick every mouse X every time I move the mouse. So it'll be like I'm drawing across the screen. Make it much easier to fill in lots of them. And even though I'm getting lots of them, it's still running relatively fast. That's cool. We just did Microsoft Paint. How excited are you? Now I just want to try one more thing. I want to try turning off the anti-aliasing to see if that helps the other version. So you remember when I did this way round, it was still slow from drawing so many pixels. Still slow, still slow, still slow. Still slow, still. But look, that's not quite the same black. I don't know if that comes across on yours, which makes me wonder something weird's going on. So I'm going to try turning off anti-aliasing. Faster. Okay, look at that. I've still got the mouse moved on, right? So it's doing that. So the anti-aliasing is a big part of what was making that slow, and it was messing up the color. If you don't know what anti-aliasing is, go have a look it up. It's just not something you should have to worry about in Comp 1000, but whenever you do any kind of programming, you always hit these things. You got to know the whole stack. If you don't, you always hit the problem when you're doing something weird. And in this case, because I was drawing a point on every single pixel, what processing was doing was when it drew a point, it wasn't just filling in that pixel. It was filling that pixel in black, and it was filling the 8 or so pixels around it in a light gray to make it look like a smoother thing. And then it would go to the next one and fill that in black and fill the 8 pixels around in light gray. And so that would, after doing that over the whole screen, which is obviously a lot more work than just filling in black, we got a whole screen of kind of light gray because they were writing over the top of each other. All right, good. We got some reasonable performance now. Reasonable? I don't know. We wouldn't call that reasonable if we were trying to sell it to someone, but we're not. We're just experimenting. It is cool to see how quickly we can build up a lot of pixels. I mean, every single one of, a lot of memory slots, sorry. Every single one of these dots on the screen is a memory slot in a two-dimensional array somewhere. Okay. So that's everything I want to talk about. Do we have any other questions before I move on? My hands are getting cold. I'm going to have to start typing with gloves. We're getting cold now. Very good. Post that on the forums. We'll see how you go. I did notice, I got a notification from the university's social media people saying that we got a mention on social media as the assignment was far too hard. I don't know what they're talking about, but I don't know. It doesn't seem that bad. No, I don't think a 2D array would be good for the assignment. No, I think you'll get by with a one-dimensional array just fine. Does anyone know which social media we got a mention in? I got no idea. Oh yeah, 1010 definitely builds on this. I mean, just go to the website, right? So we finish up on refactoring, that's our last topic, and transition to Java debug, all these other topics are in 1010. So you can just see exactly what's in 1010 by looking on the online notes. And right now, over in 1010, we're teaching recursive lists. Such fun. Oh, whatever you use that worked is fine. If it works, it works. But you can do it with just the one-dimensional array. So that's a big assumption. Maybe you've already passed 1,000. So how do you populate the array when you don't know the length it will be? That's what you use the dot length for. We never need to know what the length it is. Dot length will always give us back the length. And when you're doing a two-dimensional array, dot length gives you the outer dimension, and then when you ask on one of the inner dimensions, dot length gives you the inner dimension. All right, sounds like we're done. Nice to chat to you all again, and I'll see you next week.